Yeah, but I mostly called to talk to you about my sister.
Okay.
And she's in the same math class as me, even though she's a year younger.
Uh-huh.
And she skipped Algebra 1 because
Okay.
she did like placement test thing.
Uh-huh. Uh-huh.
And she doesn't quite know how to factor expressions.
Okay.
Factoring.
I was going to say, if she's there, go ahead and put her on, and if you like, I'll just do the session with her.
Yeah, right here.
Okay. What is your name?
Jessica.
Jessica. Spelled just like it sounds?
Yeah.
Okay. And hold on a second, Jessica. Let me open up this page that allows me to draw. And do you have some specific problems, or you want me to just talk about factoring in general?
No, just in general, and group factoring.
Okay. I'm going to show you my technique for factoring. Okay. Kind of starts with foiling. Have they taught you that expression?
Yeah.
Okay. What's that equal to?
X squared plus 2x plus 3x minus 6.
Okay, it's that times that for the x squared.
Yep.
Then it's that times that, so it's minus 2x
2x.
and plus 3x minus 6. Okay, which comes down to this. Now, all factoring is doing this in reverse.
Uh-huh.
Okay, so let's start over here on the left. I didn't pick a particularly good one to do, but yeah. So if we are going to try to split this up into two linear factors, then the first thing we have to do is split up the x squared. So how does that split up?
There's going to be an x inside of each parentheses.
Okay. Now the next step is one that I tend to focus on, and not everybody does, but it's extremely important, I think. And that is to determine what both signs are.
Okay.
Okay, that's step 2 always. Step 1 is to split up the squared term. Step 2 is to figure out both signs, and what you use is that to determine both signs. So what do they have to be? Do they have to be the same or opposite?
The same.
No, if they were the same, that would be a plus 6, right?
Oh, yeah.
Go through the process of foiling again, and the only way you can get a negative number there is if the signs are different.
Uh-huh.
So I can make that one plus, that one minus, or the opposite, and in this case it doesn't matter which.
Uh-huh.
Okay, they're both, in other words, x minus is the same as x plus. Now, the third step is to find factors of that number that do what?
I don't know.
Subtract to 1. Subtract because of that minus sign. And we're talking about the coefficient of the middle term. Well, the coefficient of that middle term is 1. So what two factors of 6 subtract to 1?
3 and 2.
And then the final step is figuring out where the 3 goes and where the 2 goes. Take the bigger of your factors, 3 is bigger than 2, and put it with the sign of the middle term always.
Okay.
So the 3 goes with the plus sign, therefore the 2 goes there. And you can kind of see how it works. Let me make one up and I'll give you some practice. I'll start with the quadratic. Use those steps that I just went through. What's the first step?
Put x in each of the parentheses.
Second step?
Look at the
Determine both
Right.
signs.
signs. Thank you.
That's a huge thing. If you can remember these in order, this will become a piece of cake. So what do both signs have to be? How would you produce a plus 10?
They would have to be the same.
Okay. So it's either minus minus or plus plus. What's it going to be in this case?
Minus minus.
Yeah, in other words, whatever the sign of the middle term is tells you what it is. Now, what do I need? I need verbalize it for me. Factors of...
You need to find what adds factors of 10 that add together to make 7.
Yeah, what are those?
5 and 2.
And in this case, it doesn't matter where I put them. I can reverse them. It's the same answer. So this quadratic only has 3 steps to it. Split up the x's, determine both signs, and figure factors of 10 that add, because of that plus sign, to that number.
Okay.
All right. Step by step.
Separate the x's in the parentheses. They're going to both have to be plus signs. And then factors of 25 that add to 10.
Perfect.
5 and 5.
Yeah, let's look at the factors of 25 first of all. It's the only ones we have. Usually, I would say 95% of the time in Colorado, you're going to get factors that are the 2 closest together. If you're talking the number 10, the 2 closest factors are 5 and 2. They're closer together than 10 and 1. So this is where you usually want to start, okay? And this factoring process is a trial and error process. Meaning it might be 5 and 5, but let me make just a minor change to the equation. Now what is it? First 2 steps are still the same.
Then you have to find factors of 25 that add to 26.
What are they?
20 and 25 and 1.
Yep. So occasionally you'll get this, but not very often. Usually most every problem they're going to give you the factors that you need are the 2 factors closest together. Now, yeah, let's talk about factoring. What we've been doing is the third type. Okay? It's not always where you begin. Sometimes you get a problem like this. Now, how do you factor that?
I still separate the x's, probably.
Actually, always begin with, can you find a greatest common factor?
No.
Actually, x is.
Oh, that counts.
In other words, if you take out an x, in other words, you can divide every term by x, right?
Uh-huh.
That's what you have left over. Now this is the one we just factored, so we know what the final result is here. Okay? So this is always where you begin. Any factoring problem is try to find the greatest common factor. Now, what if the problem was this?
Then is that 14 and 70?
14 and 20.
14, 20. Then you still find the greatest common factor?
What is the greatest common factor?
2.
2x.
2x.
Yeah, and it leaves the same thing. In other words, it leaves this simple quadratic left over. And this is important because you're going to get to where you can factor every quadratic, even if you have to use this fourth method, the quadratic formula. But the fact of the matter is the order you do it is important. You want to take out all, because notice that that's a hard problem. But once you take out the greatest common factor, you're left with an easy quadratic to factor.
Okay.
So that's usually a necessary first step. You don't want to be trying to factor it if you can take out a greatest common factor first. All right. Second thing you look for is dopes. Any idea what dopes stands for?
Exponents?
I'll give you an example. What's that called?
A perfect square?
Aha, difference of perfect squares. That's a perfect square, that's the difference, and that's a perfect square. So it's the difference of perfect squares. And this could be generalized like this. There's the difference of perfect squares. How does that factor each and every time?
Just be a minus b squared.
No, it's a minus b times a plus b. Notice that if you had a minus b squared, a squared minus 2ab plus b squared, you'd have a middle term. But when you have dopes, you don't have a middle term. It factors into the difference and the sum. In other words, these signs are always, the first one's a negative, the second one's a positive. So factor x squared minus 25.
X minus 5 times x plus 5.
Yeah. Piece of cake. What's x squared minus 1?
X minus 1 times x plus 1.
Yep. That's a hard one to see. Not everybody sees this one because they don't think of 1 as being a perfect square number, but it is. Okay. So that's the next thing you look for. Let me mix it up a little bit here. Sorry. Use this manual eraser. Factor that.
2x.
Always start there. In other words, you want to, the reason I've listed these in that order on the left, because that's the order every single factoring problem you want to do. You want to see if there's a greatest common factor, because if there is, this problem's going to be turning into a simpler one.
2x.
No, what's the greatest common factor? What can you divide that by and that by evenly?
2.
2, that's it. What's left behind?
X squared minus 50.
No. Dividing both terms by 2.
Oh, minus 25.
Right. And then when you're doing math, whenever you do that step, what I always do is immediately I multiply it back together again, make sure I didn't change it. And if I multiply this back together again, I get 2x squared minus 50, right?
Mm-hmm.
Now you use dopes to factor that x squared minus 25.
X minus 5 times x plus 5.
Okay. Now you went in that order and then that order. Notice that you'll always do those first two if you can. And then you go into factoring, which is kind of where we started. Was with factoring a quadratic. Let's talk about that for a moment.
Okay.
Start with greatest common factor. Can you do that?
No.
Okay. Next, dopes. Can you do that?
No.
Okay. So then we do the factoring. Factor that again. In steps. Step 1.
Separate the x's.
Step 2.
Look at the signs.
Yeah, that's the one everybody forgets. So I put extra emphasis on it. The reason people have trouble with factoring is because they don't do step 2. It's as simple as that. So what are both signs? And you're looking for both sides. In other words, I'm not going to come up with an answer and then figure out the other part. It's not the way I'm doing it. I'm going to solve this by doing it piecemeal. In other words, I got the x part on both. Now I'm going to put the signs. What are both signs?
Positives. So pluses.
And then finally, factors of 10 that add to the number 7.
5 and 2.
So here, we couldn't use greatest common factor, couldn't use dopes, so we had to go to factoring. Now I'm going to make it, have you had the quadratic formula?
Yes.
Okay. I'm going to make that number 9. Now, greatest common factor doesn't help, dopes doesn't help, and I can't factor it. I cannot find factors of 9 that add to 7. I can find factors of 9 that add to 6, but not 7. Okay? So I cannot factor it in the normal way. So I have to use the quadratic formula. You have it memorized?
I have it close.
I'll go ahead and do it, but you should memorize it. Everything forces you to memorize this, including all your standardized testing, the SAT and the ACT. So this is not something you can get away with not memorizing. A lot of stuff you can, but the quadratic formula, they just insist on it. Now, what is A, B, and C?
A.
And this quadratic?
X is A.
No. These letters, A, B, and C, are the coefficients, always. In other words, remove the x's and give me just what's left, the coefficients. What's the coefficient of the x squared term? That's A.
1.
B?
7.
And C.
9.
Yes, and it is plus 9. If it were a minus 9, then C would be minus 9.
Okay.
Plug it in.
Hold on.
Just before you solve anything, just plug it in, and then we'll do all the math later. And that's another key I think is important, is don't try to do 2 steps at once. In other words, don't even do the b squared in your head. Certainly not the 4ac. So let's just plug it in, and then you'll see what I mean.
-7 plus minus square root 7 squared minus 4 times 7 times 9 over 2
Hold on.
times 1.
4 times what?
Times 7 times 9.
It's 4ac.
times 1 times 9.
All over that, right?
Mm-hmm.
Now let's go through how we simplify that. And remember those 4 steps. That's pretty much the same 4 steps you do every time you're looking at factoring a function, at least for now, until I get you to harder stuff. Okay, how are we going to simplify this? Where are we going to start?
I start with the 7 squared minus.
Okay, good. That's where I start also. So,
7 squared.
what is that? That's 49.
Minus 36.
So that's 13.
Over 2.
Now, do you know how the plus minus works? What are both solutions?
Um,
One of them is using the plus.
So you plus square root 13 over 2, or you just minus square root 13 over 2?
And that's the second solution. In other words, the only thing that changes is that plus minus. The first case, you use the plus. Second case, you use the minus. And that is both solutions. In other words, if I go back up to this originally quadratic here, and I plug in either one of these solutions, it'll equal 0. Okay. And even though that wasn't the task was just to factor that, frequently the task will be this. You set it all equal to 0 and you solve for it. And when you have to use the quadratic formula to do it, like we just did, then what you're doing is finding the 2 zeros. And by way of illustration, let me do one thing here. What's the shape of a quadratic? What's the figure called?
Square.
Parabola.
Parabola.
Now, I'm just going to pretend that that's the parabola. Okay? Here's our 2 zeros. One of them is minus 7 plus root 13 over 2. It's the x value. This one over here is minus 7 minus root 13 over 2. So when you are solving a quadratic, which is a parabola, for its zeros, what you're finding is where the parabola crosses the x-axis.
Okay.
Okay? And that's why it's set to 0, because that's what the y value is. Whenever you're on the x-axis, y is 0, right? At that spot and that spot, y is 0. So that's why you're finding those zeros. Okay. Let me think here, what's the next thing I want to tell you about factoring? Okay. Factors are anything where that first x squared term has a 1 coefficient. I'm going to call that elementary. Easily done. Using the 3 to 4 steps that I showed you. You separate the x's, you determine both signs, and then you find factors of the constant that add or subtract to the coefficient of the middle term. Okay? What if I have a quadratic that's like this, where that first term is not a 1? Let me think just for a minute here. I got to figure out this math. Okay, I think this works. It's not what I want. Hold on. Yeah, no. Let's go ahead and just make up a number. And then I'll figure out what works, what doesn't here. Let's say plus 9. Okay. Now, hold on, let me check something. Okay. Here's our quadratic. Okay.
Okay.
This is secondary type quadratics. And don't worry about the terminology. It's my terminology only.
Okay.
The thing is that these are always easy. Worst case scenario is you have to use the quadratic formula. These are a lot tougher. All of those simple rules kind of go out the window. The first couple are still the same. So let's try to do it using the first two rules.
Separate the x's. Separate the x's.
Okay, how am I going to do that?
2x.
Yeah. It's not x and x. In other words, these two things have to multiply together to give you 2x squared. And they do now. Second step?
Figure out the sign so they're both pluses.
Third step? It's factors of 9, but you got to throw out the rest of them. It's not factors of 9 that add or subtract to anything. It's just factors of 9. Tell me all the factors of 9.
1 and 9, 3 and 3.
Which one am I going to try first?
3 and 3.
Does that work? And by that I mean, does it produce the correct middle term? I know it produces this term, and I know it produces that term. But does it produce a plus 9x in the middle? Well, this middle term comes from the inside and the outside added together. So if I'm trying to figure out if I produce the proper middle term, I have to do this double smiley face. What's the inside multiplied to?
3x.
What's the outside multiplied to?
6x.
What do they add to?
9x.
Our middle term. Bingo. That's the result. 2x plus 3 times x plus 3. Only in this case, this process, part of that process right there is an integral process in solving it. You know what I mean? When you're dealing with an elementary quadratic, this double smiley face is a check mechanism. In other words, you can check your answer using it, but it's not an integral process of solving it. Whereas anytime this number is not 1, in other words, whether it's 2, 3, 4, 5, 6, it's a secondary quadratic. And necessarily harder. Now we got 2 minutes here. Let me just give you one quick one. And I have to do it this way just because I can't figure it out in my head backwards. All right, let's factor this. Notice I do not have a greatest common factor, and it's not dopes. So I'm going to do it as a secondary factoring problem. First step.
Separate the x's, so 3x in one parentheses, x in the other.
Next step.
Evaluate the signs. So One is going to be plus, one's going to be minus.
And notice in this case, they're not, it's not the same, putting the minus on the left and the plus on the right. So I have to consider both.
Okay.
Give me factors of 2.
2 and 1.
Now it's totally a process of elimination or trial and error. In other words, I'm going to take these 2 factors and I'm just arbitrarily going to apply them right there. I'm going to put the 2 there and the 1 there. And I'm going to see if that works. Does it?
2 times x is 2. No.
No, that gives you this, which would be minus 1x in the middle. So what do I have to do? I just have to move the 2 down to here and the 1 down to there, get rid of that. And now that becomes a minus 2x in the middle, a plus 3x in the outside. Add them together, you get the middle term.
Okay.
So that's how you do the harder ones, is by trial and error. Regardless of what technique you're using. I know they teach a lot of people this California technique or the diamond technique. Yeah, I find those particularly confusing and complicated. So this is my technique. Call it the double flat smiley face technique.
I like it.
Okay. Jessica, we only had a half hour scheduled, or Joseph only scheduled a half hour, so this is a good place to stop. I hope I've helped you with your factoring a little bit. And if not, there is a recording of this that I will post, and you can watch it again if you need to, if it's helpful.
Okay.
Okay. Joseph should have the location of that. It's my YouTube channel, and it's a YouTube file that allows you to, pause, fast forward, rewind, and it's just the audio of this session along with everything that's you see on the screen.
Okay. And in the future, should me and Joseph do our sessions together or separate?
You can do them separate. I have no problem. Yeah, I mean, have him tell you how you get started. If you're both using the same computer, then it's no problem. If you're using different computers, then you would need to get the GoToMeeting software on the computer that doesn't have it on there yet. But feel free to call me at the next session if you want help in getting started. If Joseph isn't there to help you start, but once you do it once, that's the last time you'll need help. And then from that point on, you can just schedule it on your own. And if you are scheduling for you, go ahead and schedule it as Jessica.
Okay.
And if Joseph is scheduling for him, have him schedule it as Joseph. And I couldn't care less if both of you sit in on both sessions. So I don't care. If you're both taking the same class, if that's helpful to you, that's fine.
Perfect. Thank you.
You're welcome. Talk to you next time.
Yeah.
Bye-bye.
Bye.